Hi, today I am going to take Voltaire use case. What is Voltaire technology? It's a technology that allows you to make voice calls over 4G LTE data network instead of the traditional circuit switched voice network. This can provide n number of benefits such as higher call quality, faster call setup, and the ability to use data sources while you are on the call. Let's see the agenda of this section. The first section includes an architecture which describes you the end-to-end Voltaire voice call. And the second section is a recap of the key components used in this setup. And third section is the most exciting part, live demo. So this is the architecture. Here at one end you can see the 4G phones. And here we for this setup we are using Samsung 4G phones and it is connected with the E0 B. Here basal P0 B is acting as the base station where the UEs are getting connected and it will it will be the connecting the user devices to the core network. You can see it as an intermediate between the core network and the user device. Here we have a most important component is like EPC. It consists of MME, S gateway, P gateway, PCRF and HSS. MME will deals with the mobility of the user devices, whereas the HSS will have the subscription data of the users, and S gateway and P gateway deals with the user traffic. All this process going on, there will be someone who decides on the policy controls and charging. That part is done by PCR. So let's see the next part is the IMS part. So, what are the components there in the IMS part? ICSF, SCSF, and PCSF. These all the components are used for delivering multimedia services like IP networks. So we are making audio and video calls. So hope you will understand the importance of Camilio IMS here. So this is the overall high level view of Voltaire use case. Let's see the calling part. My Samsung phone is like maybe two phones are there in the lab. So one phone is initiating the call. So the call request is sent to the E node B first, and the E node B receives the call request. It is responsible for managing all the resources and acts as a bridge between this user equipment and EPC. So this call request is then forwarded to EPC. Like I mentioned earlier, MME will do its job. S gateway, P gateway deals with the signaling part and all, and HSS will deals with the all subscription data. That means technically speaking, it will do the authentication and authorization. We have to like coming to the configuration part. Let me tell you one thing. Here we have one HSS part. Here we will have a PYHSS, an external HSS that is not mentioned here, but it is inbuilt. So in both of the components, we need to give the subscription data while configuring. So after this EPC part, the call request will go to this IMS part. It is a Docker based one. So it handles the signals for the call and it will route this to the correct destination. So coming to the call completion. Finally, the call is routed to the correct destination, completing all the procedures over this LTE network. So, I'm giving an overview of the components used here. Here I have both phones, Samsung 4G UE and sorry, Samsung 4G and the E Node B as I mentioned earlier, it is basal E Node B and EPC means evolved packet core which have that much components and I hope you remember the functionalities of that and the Camillo IMS part which deals with the multimedia services. So let's go to the exciting part of the live demo.
This is our lab setup. Today we are going to do 4G deployment. This is the most important part, basic video, where the units are going to get connected. This is treated as E node B. And this is the server, we deployed Open5GS and all the IMS components.
Here I'm going to show the server access and the different components of this deployment. Here we deployed all the IMS components as well as the Open5GS components on a Docker based platform, and the 4G Volte deploy.yaml file is responsible for bringing up all the components. I'm going to run this command. Parallelly, I am going to check the logs. See, you can see an IP rising up 172.16.7.241, which corresponds to E node B, which I have shown you as a basal radio in the lab setup. So I am picking this IP from here. We have a GUI based platform for this basal radio. And here you can see the cell status as active and the connected state of the basal radio here. Again, if I run this docker ps command to see the Docker processes, you can see the different components of Camellio IVMS and Open5GS here: PCSEF, MME, ICSEF, SGWU, SWC, likewise PYHSS and all. Coming to the GUI platform again, here this is the Open5GS HSS part, GUI based part, where all the subscribers are added here. 5210 and 5226 are the subscribers which we use for the live demo part. As we have a PYHSS for the setup, we can see the subscriber details here. If you want to see the IMS subscribers, let's try it out. Yeah. As I mentioned, 5210 and 5226 are the two subscribers which is used in the live demo. Here, these subscriber information are added in the PYHSS, which is a part of Camellio IMS. And here in the Open5GS also, the same subscribers added in the GUI part. So let's go to the live demo. Now we are going to test audio call. I am going to call from this number to this number. Let's see how it works. Let's try again. The call is coming. So I'm going to accept it. In both of the screen you can see I'm going to disconnect it. Hence the audio call is tested. Let's test the video call part. I'm going to call from the same number. Before we saw the audio call part, now it's video. The call is going. Trying again. Now the call is coming on the second phone. I accepted it. You can see the quality of video on both of the phones. So the video call part is tested.